So today we are looking at chapter number 4. We are looking at chapter number 4. And this chapter is called Time Value of Money. Time value of money. Time value of money. So we are going to begin, and we will write notes and write that a sharing today is worth more than a sharing tomorrow. A sharing today is worth more than a shilling tomorrow. Than a shilling tomorrow. First stop. The future value into brackets FV, the future value into brackets FV is the value at some time in the future, is the value at some time in the future of a present sum, of a present sum of money, a present sum of money, or a series of money, or a series of money. A series of money. Full stop. Another point is the present value, PV, the present value PV is the current value, is the current value of a future amount of money, of a future amount of money or a series of future money, or a series of future money. Full stop. Simple interest is the interest, simple interest. Simple interest is the interest earned, only on the original amount. 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 Another point is compound interest. Compound interest. Compound interest. Compound interest is interest earned. Is interest earned on the original amount. On the original amount. On the original amount and on any previous interest earned. And on any previous interest earned. On any previous interest earned. Okay. Another point is the process of finding present values. The process of finding present values is called discounting. Is called discounting. First up. The equation used for finding future value of a single amount, future value of a single amount is given as FVN is equals to P naught 1 plus R you raise power N, which is equals to P naught times future value interest factor at R% and N. Ann Karaja, good evening. Karibu sana. Where P naught is the present value, which also we refer to as the original value. The present value, some people call it the original value. R is the annual rate of interest. Is the annual rate of interest. Is the annual rate of interest. N is the number of periods. Number of periods. Number of periods. And these are FVIF is called future value interest factor. Future value interest factor. Future value interest factor obtained from tables. From tables. So this topic that we have begun, called time value of money, it has to do with the question of a sharing today. Is it the same as a sharing tomorrow? A sharing today, is it the same as a sharing tomorrow? And the argument is that the value of a sharing today is greater than the value of a sharing tomorrow. And why that is so is, today when you have your money, you can be able to use it compared with someone who does not have his money now. Number two, hiyo pesa ya kuabiriwa kesho, you may not get it. So there is some risk. Kuna uwezekano unaweza ikosa. But yenye uko nayo saa hii, you have it. There is no risk. So the topic on time value is simply telling us that if you have money today, you are better than having the money tomorrow. And this is the concept we use in accounting, where we say, if someone has your money, you should start asking for that money immediately. Immediately mtakubaliana atakulipa, you start reminding the person. And equally, if you have someone's money, you should take the latest time to pay. You should take the latest time to pay. Obviously, by ensuring that you guard your credit worthiness. So that is about the time value of money. Now, in this discussion and in the entire financial management, there will be these terms that will keep on coming across. One is the present value. So present value is the worth of the money now. The worth of the money now. And it is used when we are referring to some money that is in future. If you expect some money in 5 years from now, what is the value of that money now? There is another one, future value. if I have some money today, I have like 1 million today, in 10 years, how much will that be? That's called future value. Now, the process of getting the present value of the future is called discounting. And the process of getting the future is called compounding. This compounding. I think we should have noted that. Able to guess here because you have not captured in the note. The process of getting future value, is known as compounding. The process of getting future value is known as compounding. Yeah, you need to know what is compounding. Okay, that's fine, Anne. So I was saying you need to know what is compounding and what is discounting. So compounding ni kutoa pesa ya leo uipeleke kesho. Discounting ni kutoa pesa ya kesho uilete leo. Yeah. Now, the formula that is used is as you can see, and we shall use it in a while. Let's have a simple example. Example. An investor has invested. Kenya shillings 650. Kenya shillings 650 at an annual rate of 15%. At an annual rate of 15%. Full stop. Determine the future value of the investment after 3 years. Determine the future value of the investment. Future value of the investment after 3 years. If semicolon and point number 1, simple interest is used. Number 2, compound interest is used. And when we say used, A, annually, semi-annually, and C, continuously. So let's have the solution. Let's have the solution. So the first one is simple interest. So simple interest. If you're using simple interest concepts, the formula used is interest is equals to principal times the rate times the time. You divide by 100. So in this case, the person invested 650,000 at a rate of 15% for 3 years. You divide by 100. So work that out and give me the answer. Kansiro is no calculator and bado kwa barabara. Rose, uko na calc? Okay, then we can rely on you because hata mimi sina. Give us the answer then. $292. Juu kwani nashuku hiyo jibu yako. That's a very high rate of interest. Itumia simu 650,000 times 15 times 3. Haya. 292,500. That's a very good investment. Okay, so amount in 3 years, it is the principal plus interest. So ile pesa atapata, it is these 650,000 plus 292,500. So give us that answer. Yeah, 942,500. Yeah, so that is what you get when we compound or when we use simple interest. Now, annual compounding. Let's see what happens with annual compounding. If we are compounding annually, the future value, which some people prefer to call amount, can also call amount, it is the P. Now, P is still this one, principal, or P naught, 1 plus R, you raise power N. So, there's going to be 650,000 times 1 plus 0.15, you raised power 3. You raised power 3. Aha, Rose. Ready tunangoja. Mhm. Rose. Okay, 988 566.75. Good. 988 568.75. Haya. Next is semi-annual compounding. Semi-annual compounding. Now, when you are compounding more than once, the amount is normally given as P 1 plus R, you divide by M, then you have M multiplied by N raised, where M is the number of compoundings. Number of compoundings in a year. Number of compoundings in a year. So if that is the case, then when you're told semi-annual, we are going to have two. We are going to have two compoundings. So it is going to be 650,000 times 1 plus 0.15. You divide by 2. You raised power 2 times 3. You raised power 2 times 3. Waiting for us to give us the figure. Yeah, 1,003,000. 1,003,145.99. Aya. Then there is what we call continuous compounding. Continuous compounding, it is P times E raised power Rn, where E is 2.7182. So in our case here, we are going to have A is 650,000 times 2.7182, which is raised power 0.15 times 3. So if you're doing continuous compounding, then 19,355. 355.35. So that is how we go about doing the compounding. All right, let's now discuss something else called annuity. Let's discuss something called annuity. 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 And we write that an annuity is a series of payments. Is a series of payments or receipts. Or receipts of equal amounts. Or receipts of equal amount. As an annuity is a series of payments or receipts of equal amounts. First up. There are two types. There are two types. One, ordinary annuity. Ordinary annuity. And write that this is an annuity where cash flows occur at the end of each period. This is an annuity. This is an annuity where cash flows occur at the end of each period. At the end of each period. Number two is called annuity due. Annuity due. And write that this is where cash flows occur at the beginning of each period. 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 Okay. Then we write that the future value for an ordinary annuity is computed as the future value for an ordinary annuity is computed as future value of ordinary annuity is equals to the annuity now 1 plus r, which is raised to power n, u minus 1, then the whole of this you divide by r. That's how we get the future value of annuity. Alternatively, you can say it is 8 times the future value interest factor of annuity at R% and n years. Where A is the annuity. Yeah, that's how we go about it. Now, this one, when you see it this way, it is read from the tables. We will be reading from the tables. We will be reading from the tables. For an annuity due, for an annuity due, for an annuity due, the future value of annuity due, the future value of annuity due is given as A 1 plus R. You raise this to power N. You minus 1. You divide by R. You multiply by 1 plus R. Yeah, so that is how you get the future value of an annuity, the future value of the annuity, future value. So let's have an example. 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 Example inasoma hivi. An employee has decided to deposit. An employee has decided to deposit 1,500,000 shillings. 1,500,000 shillings per year. Per year. Into a retirement benefit scheme. Into a retirement benefit scheme. Retirement benefit scheme for the next 6 years. For the next 6 years. For the next 6 years. Beginning at the end of the current year. Beginning at the end of the current year. First of all, he expects to earn an interest. He expects to earn an interest of 12% per annum. Of 20% per annum. Full stop. Determine the lump sum. Determine the lump sum at the end of year 6. At the end of year 6. At the end of year 6. So let's have the solution. And we take a case of ordinary annuity. If it's a case of ordinary annuity, that is money received at the end, then the future value of ordinary annuity is the annuity itself, 1,500,000 times 1 plus R. So R is 12% raised power 6. Then you minus 1. And then the whole of this you divide by 0.12. That way. That is how you get the future value. Yeah. 12,172. 172, 783.56. Good. All right, let's now see what would happen if it was annuity due. If it was annuity due, the future value of annuity due is the annuity itself, the 1.5 times 1 plus 0.12 raised power 6. You minus 1. You divide by 0.12. Then you multiply by 1. Actually, it's just this amount. You just take this amount and multiply by 1.5. Yeah, 13,633. 633, 517.58. Okay. Okay, then from there now, I want us to write, we are still under the annuity. We now look at growing annuity in perpetuity. Growing annuity in perpetuity. Perpetuity means forever. The present value of this, if you want to know the present value of an annuity that is growing continuously, it is given as A naught, the current annuity, 1 plus G, 1 plus G, you divide by R minus G, which some people will give as A1. You divide by R minus G. R minus G. Where this A naught is the annuity for the year just ended. Annuity for the year just ended. And then A1 is the expected annuity. Expected annuity. Obviously, in the next year, G is the annual growth rate. Annual growth rate. R is the cost of capital. Cost of capital. Yeah, that's how we go about it. That is annuity growing in perpetuity. Then we have another one here. Annuity growing in defined periods. annuity growing in defined periods. The present value is given as A, 1 minus 1 plus G. You divide by 1 plus R. You raise this to power N. Then you divide the whole of this by R minus G. That way. Okay, so let's have an example. An example. We write that a company whose cost of capital is 12%. A company whose cost of capital is 12%. Is 12%. Paid a dividend per share. Paid a dividend per share. Paid a dividend per share of shillings 3.22. Dividend per share of shillings 3.22. Of shillings 3.22 in the year ended. In the year ended. The year ended. Full stop. These dividends are expected to increase. These dividends are expected to increase. These dividends are expected to increase at a constant rate of 5%. Are expected to increase at a constant rate of 5% for the next 6 years. For the next 6 years. Stop. Determine the present value of these dividends. Determine the present value of these dividends. Determine the present value of these dividends. Present value of these dividends. Yeah, so this is a case of defined a case of a defined period. So if it's a defined period, the solution will be the present value will be equal to, you get the annuity. The annuity is 3.22 times 1 minus 1 plus G, the growth rate. The growth rate is 0.05. You divide by 1 plus the cost of capital. You raise power n, which is 6. Then you divide the whole of this by 0.12 minus 0.05. Yeah, so work out that. Work out that. Okay, I can see 14.76. 14.76. 14.76. Good. So that is how you go about it. Let's now look at something called differential annuity. Differential annuity. Differential annuity. And we write that these are different annuities. These are different annuities in different portions. In different portions. In different portions of a project's economic life. Of a project's economic life. Of a project's economic life. Full stop. They are discounted using differential discounting factor. They are discounted using differential discounting factor. Differential discounting factor. And then added together. And then added together. And then added together. To establish the total present value of the cash flows. To establish the total present value of the cash flows. To establish the total present value of the cash flows. The total present value of the cash flows. Yeah, so that is when now they are not constant all through. They are changing, but they remain constant for some period, then they change constant that way. So let's have an example. 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 A 20 years project is expected to generate the following annual cash flows. A 20 years project is expected to generate the following annual cash flows. To generate the following annual cash flows. So we have the years. We have the annual cash flow. 1 to 5. 1 to 5 years, we have 450,000. 6 to 11. 6 to 11, we have 720,000. 12 to 20. 12 to 20, we have 1080. 1080. Then you write, the cost of capital is 12%. The cost of capital is 12%. Cost of capital is 12%. Full stop. Determine the present value of these cash flows. Determine the present value of these cash flows. Determine the present value of these cash flows. So we have the solution. We are going to have the years here. We'll have the annuity. Then we'll have the discounting factor. Then we have present value. Present value. Have present value. So I want us to use the what? I want us to use the tables.
So from here, we can now proceed to another item.
I want us to use the tables that are in our past papers. Have you seen them? I sent you the past papers. Have you seen the tables? At the end, of the past papers, there are two tables. There are two tables. So if you are there, for year 1 to 5, where the annuity is 450,000, we will go and get the PVIFA at 12%. 12%, 5 years. Or we just write 5. So read. So I've sent, fungua huko mwisho, the last table. Haya, now, if you have seen the tables, I would like you to read for me. You go to line 5, 5 years, and 12%, the value that is there. So Anne can see that. The others, Royce. Okay, so if we are good with that, this is 3.6048. So the present value, now multiply this 450,000 by this. Sixteen 22 160. Then 6 to 11. 6 to 11. 6 to 11, the amount is 720,000. So what you do, you get the PVIFA at 12 for 5 years. You minus, for 11 years. You minus the PVIFA at 12% for 5 years. So enda now usome 11 years. 11 years. $5.9377. So you take now 5.9377, you minus 3.6048. So you minus this one that we already had factored. 2.3329. So now multiply this by this 720,000. $1,679,688. Then we have 12 to 20. 12 to 20, the amount is 1080. So you will now get the PVIFA at 12% for 20 years. You get the PVIFA at 12% for 11 years. So read for the 20 years. $7.46. You minus 5.9377. $1.5317. So multiplied by this 1080. $16.54 to 36. So now add the three of them. Add the three of them. $49.56. 0.84. So that is how you get the present value if the annuity is for different segments. Yeah, that's how we go about it. So for your assignment, for your homework, or your assignment, you can consider looking at in your past papers. In your past papers, you check this question of May 2018. May 2018 and question 4D. So you look at that. Then when we pick up from there tomorrow, we shall do something else. So thank you very much. Good night. See you tomorrow, same time.